Hello again. Welcome back. We're here for Properties of Quadrilaterals Part 2. So we're hitting on our second kind of group of quadrilaterals, different properties, and applying them. So to start off again, let's look back at our family tree. Remember, all of these properties get passed down as you see those lines kind of connecting things. So the things that we will be talking about today, the quadrilaterals that is, are behind the yellow block, trapezoid and isosceles trapezoid. Specifically, we're focusing really on the isosceles trapezoid. It's got more properties. It's got cooler stuff going on. So that's what we're gonna look at. Then on the right side over here, also passing things down from the parallelogram is the rectangle. Okay, so all those properties from parallelogram are going to apply to a rectangle. And then our very last one, our baby of the quadrilateral family tree, getting all properties from parallelogram, rectangle, rhombus, all that stuff is the square. Square is going to get all those things combined. So let's check them out. First one we have is the rectangle. So properties of a rectangle. First thing we think of is, hey, it's getting kind of the things passed down from the parallelogram. So first thing we write down is everything from a parallelogram also applies to a rectangle. Next one there, something that's added in here is the fact, well, what makes it special? All angles are congruent equal to 90 degrees. And then a special property that comes from that pretty much is the fact that the diagonals are congruent. Okay. Now let's check it out, apply those properties a little bit. All right, thinking back, what do I know and what can I prove? So I got this 10 centimeters here. I know from a parallelogram that the diagonals bisect each other, and from a rectangle that the diagonals are equal. So if this is 10 centimeters, so is that, so is this, so is this. So right away, knowing those properties tells me x is 10 centimeters. Okay, now I gotta find y down there, which gets a little trickier, but, the number one shape we look at all the time, even within other shapes, are these right triangles. And I see that I have one side here given to me as a 12. This is 10, and this is also 10, making a total hypotenuse of 20 from here to here. And lastly, I have y down here that I need to solve for. So let's set up our best friend, the Pythagorean theorem. A squared plus b squared equals c squared. My a in this case is 12. My b is y, so I'll change it to y here. Equals, c is my hypotenuse always, so 20 squared. All right, 12 squared is 144. Plus y squared equals 20 squared is 400. And I want to get y by itself, so I subtract 144 to get y squared equals 256. Square root of that gets me, let's see, 16. There we go. Got our answers. So knowing the properties and knowing a little bit of extra on top, always going to help you out. Let's check out another rectangle. Again, make sure you're writing these problems down. It's only going to do you so much to just watch. Doing it along with me is going to really help you out and really help solidify that idea in your head. Okay. I got no lengths involved here, right? They're all angle measures. And I know that the top and bottom are parallel, so I see this angle up here being 35, this angle down here being alternate interior, so x, 35 degrees. Notice, by the way, I'm not going in alphabetical order. I'm going with whatever I see first, whatever makes sense to me. And as I'm saying that, I realize, hey, there's a little right angle symbol up here. So that angle is 90 degrees. The angle that I know is 35, so what's left over is my y, 55 degrees. Spectacular. Very nice. All right, now I think I gotta figure something out. I realize, looking back at that previous problem I just did, the diagonals bisect each other and they're all equal. Marking just those two, it might be clear to you, I've got an isosceles triangle down here. Oh. That means the base angles must be congruent. Z has to also be 35 degrees. Awesome. Okay, 35 and 35 gets me 70. That isosceles triangle down there has to add to 180. I get 110 for W. Awesome. There we go. Found all my angles. And that's my rectangle. Properties of a square. Okay, let's get one more now. Again, square is like the baby of the family. It's got so many properties, but if I learned them all from the previous shapes, really I know a square technically is a parallelogram. A square is also technically a rhombus because all sides are equal. It's also technically a rectangle because all angles are equal. So if you got a square, you could really call it a rectangle. You could call it a rhombus. You could call it a parallelogram. Square's the most specific. That's best to say, but the properties apply for all of them. Okay, so square. Let's see. I want to find x and I want to find y. Thinking through my properties, I know it's a property of a rhombus that the diagonals are perpendicular. Boom. X is 90. Okay, that's a good quick one to get. Next thing I know also from a rhombus is that the angles are bisected by the diagonals, meaning those two are cut right in half. So y is 45 degrees. And that's a big key for some other things as well. You may remember special triangles called our 45, 45, 90 right triangles. This is where it's going to come back and pay some dividends if you remember it. Okay, now I got to find the area. Hi-yo. All right, find the area. Could do it a bunch of different ways. But let's do it this way. I know that's 5 right here. I know that the diagonals are bisected and equal. So I'm going to find 5 here. I'm doing this in the thought, well, I know that 5's there. I'm doing this in the thought that I want to find a side length of my square. If I know the side length of my square, I can find the area pretty quickly. So, Pythagorean theorem is one option to go with here. 5 squared plus 5 squared equals c squared, or x squared, whatever you want to call it. 25 plus 25 equals c squared. C squared equals 50, meaning c equals, a side length in this case, equals 7.071. Okay, that's the side length. That is this side length here, it's this side length here, it's everywhere. So to find the area, all I have to do is take that 7.071 times itself, or let's be smart about it, square it. Because it's a square, remember? And surprisingly, I get an answer of exactly 50. Okay. 50 units squared. That might kind of tip you off and be like, something's going on there. Oh, sorry, not units. Inches squared. Okay. All right. Let's see now. That's the old-fashioned Pythagorean theorem way. The next one I might do using a little trick. So, give me the square right. Find x, find QA. All right. Now, this time I know the side length, and it's a square, so all side lengths are the same. So this is also 20 feet. QA is what I want to find, and I might notice something here. It's a right triangle with 2 equal sides. That's my isosceles right triangle. In other words, my 45, 45, 90 right triangle. And I know some special rules for that. I know that the short leg times root 2 is the length of the hypotenuse. So if my short leg's 20, QA, no, not root 3, sorry, root 2. This is 20 root 2. Look at that. Notice you could do the Pythagorean theorem again. You'd do square 20 squared plus 20 squared equals c squared. You'd get, let's see the decimal version, 28.284. Either one of those works. I'm going the shortcut method this time. So 20 root 2. All right, next one. Let's see. I want to find x, and I know those diagonals are being cut in half. So hey, take 20 root 2 divided by 2. Boom. 7 root 2. Done. Look at that. Again, you could get that decimal version, which would be approximately 14. All right. Very important, guys. I try to pass on as much knowledge as possible. Some life advice. Now, this is from a dear friend of mine. He didn't go meet up with his friend, so he said he should have gone to that gig. He should have listened. Be there or be square, they said. He thought, nah, I won't go. What's going to happen? Now look at him. He's square. So, just remember, take advantage of all your opportunities. Okay, last shape, the isosceles trapezoid. First property, really how we identify it. One pair of parallel sides, non-parallel sides are congruent. Also, sorry, I missed that. Both pairs of base angles are congruent. Okay. Also, diagonals are congruent, very similar to the rectangle. And lastly, consecutive angles between bases are supplementary. All right, we're going to see that all pretty clearly in this first problem here. So, base angles are congruent. This is equal to this, is what that means. So, y is 56 degrees. Look at that. The last one I revealed there, consecutive angles between bases are supplementary. That means angle x and the 56, those two are supplementary. So 180 minus 56 gets me 124. And that's my answer there. What is that? X, 124 degrees. Perfecto. And then guess what? Both pairs of base angles are congruent. Technically, these are base angles as well, and that's also 124 degrees. Cool. That's nice. Let's do it again. Now, coincidentally, I've got 56 degrees up there. Oops. Oh, well. Anyways, now I've got two isosceles trapezoids put together, basically. Don't get overwhelmed. That's all well good. Consecutive angles are supplementary. Hey, I already did that math, so I know that this one is my 124. Okay, because I know that these two angles must be supplementary. Whoa, now I'm tripped up. Now what am I going to do here? Well, that 120 isn't sitting there for no reason, right? I see these three angles together making a familiar shape, which is a circle, which is a total of 360 degrees. So along with the fact that there's a 120 and a 124 here, what I want to do is subtract them and figure out what's left over. Let's get out my handy dandy calculator for it. 360 minus 120 minus 124. What's left over there is 116 degrees, and that's my missing piece of the puzzle here. This is 116 degrees. And now I can go back to those same properties. Base angles are congruent. These two angles are the same. So Z is also 116. And the last one here, the consecutive angles between bases are supplementary. So 180 minus 116 gets me 64 degrees. And that tells me X down here, 64. Isn't that nice? All right, ladies and gentlemen, that brings a wrap to our last video here. Here's the end of our family tree. Remember, all those properties get passed down, so think about the properties for a parallelogram. They're going to apply for all those shapes down there, and so on. Good job. See you out there. Keep up the good practice.